When it comes to solving its biggest challenges, AI is increasingly looking to nature for ideas. Seriously, from the human brain to a beehive, biology offers these incredible blueprints for building smarter technology. And today, we're diving into how the humble ant colony is inspiring a totally revolutionary new way of thinking about artificial intelligence.
Okay, to really get this, let's start with something we've all been through. Think about a giant WhatsApp group chat. It's just pure chaos, right? You've got conversations spiraling out of control, old arguments popping back up, a few people dominating the whole thing while everyone else just goes quiet. It's a total coordination nightmare.
And that gets to the heart of the problem. What you're dealing with is a complex, dynamic system with a million moving parts. In the digital world, whether it's that group chat or, say, a global shipping network, trying to control everything from one central point is basically like herding cats. It's just messy, inefficient, and almost always ends in chaos.
But imagine for a second, what if you didn't have to wrangle that chaos all by yourself? What if, for that insane group chat, you had a dedicated team of specialists working behind the scenes, each with one specific job, all working together to keep things on track?
So let's break down who's on this dream team. First up, you've got the historian, an agent that remembers every single argument you've ever had so you don't repeat them. Then there's the vibe checker, which can actually sense the tone. Is that sarcasm? Is someone getting angry? You'd need a diplomat who knows exactly when a heated conversation needs to be taken into a private chat. You'd have an analyst who notices who's talking a lot, and, more importantly, who has gone silent. And finally, the coordinator, who takes all of these insights and comes up with a clear, simple plan of action.
Okay, so this whole dream team thing, it sounds cool, right? But it's not just some fantasy for managing your digital life. It's a really powerful concept that is becoming a reality right now in the world of AI. We're seeing this massive shift away from relying on one single, giant, all-knowing intelligence to harnessing the power of a team.
And this brings us to the official term for it, multi-agent systems, or MAS for short. At its core, a MAS is exactly what it sounds like, a system where you have lots of autonomous agents, our little specialists, that work together to solve problems that are just way too big or complicated for any one of them to handle alone.
Think about it this way. Your typical AI, like a chatbot, is like having one brilliant genius on call. It's incredibly powerful, sure, but it has its limits, and sometimes it just makes stuff up. That's what we call hallucinating. A multi-agent system, on the other hand, is like a whole coordinated team of experts. Each individual agent might be simpler, but because they're all working together and checking each other's work, the system as a whole becomes way more reliable, robust, and accurate.
So where did this awesome idea of a team of specialists even come from? Well, believe it or not, engineers look to one of the best project managers on the entire planet, Mother Nature. And specifically, they got fascinated by this idea of swarm intelligence.
And this quote really hits the nail on the head. The whole idea is that an individual ant, on its own, is pretty simple. It doesn't have some grand master plan or a map of the world in its head. But as a group, an entire colony of ants can solve unbelievably complex problems, like figuring out the absolute shortest, most efficient path to a food source.
It's this beautifully simple, yet super effective system. An ant wanders around, finds food, and on its way back to the nest, it leaves behind a chemical trail of pheromones. Other ants smell this and follow it. The more ants that use that same path, the stronger the scent gets, which creates this powerful positive feedback loop. But here's the really clever part. The shorter paths get reinforced faster because the ants can do the round trip more quickly. At the same time, the scent on old, long, or useless trails just evaporates and is forgotten, which lets the colony constantly adapt to find the best possible solution.
Okay, the ants analogy is great, it makes a lot of sense. But how do we get from ants in the dirt to actual code running on a computer? What even is an AI agent in the real world?
Well, according to the researchers who actually build these systems, a true agent needs to have 4 key properties. It has to be autonomous, it has its own goals and can manage itself. It's reactive, meaning it can perceive what's going on around it and respond. It's social, so it can talk to and interact with the other agents. And finally, it's proactive. This is a big one. It takes initiative to get things done. It doesn't just sit around waiting for instructions. It's an active player, not a passive tool.
So how do all these agents actually get anything done together? This is where it gets really interesting. They don't just go in and change things directly. Instead, each agent puts forward an influence, basically a suggested action. Then, the environment itself reacts based on all those influences combined, all at once.
This is a super important principle because it allows for tons of complex actions to happen simultaneously without the agents tripping over each other. And you can see the inspiration from nature so clearly here. I mean, look at this. On the left, you've got a diagram of a complex natural ecosystem. And on the right, an engineering model for a multi-agent system. The parallel is just undeniable. Engineers are pretty much building artificial ecosystems to solve our most complex problems.
All right, so we've covered the what and how, but what's the real payoff here? Why go through all the trouble with building a team of agents instead of just trying to build one single gigantic super AI?
Well, the advantages are just massive. First, these systems can solve enormous problems by breaking them down into smaller, manageable pieces. We're talking about things as complex as designing and building an entire airplane. They also massively increase accuracy because the agents can review and double-check each other's work, which is a great way to fight those AI hallucinations we talked about. The whole system is way more robust too. If one agent fails or goes offline, the others can adapt and keep going. And finally, it's incredibly flexible. You can add new specialist agents or remove old ones without having to tear down and rebuild the entire system.
But with all this autonomous power, all this teamwork, there's one final piece of the puzzle that is absolutely 100% critical. And that is the human in the loop. See, this isn't about AI taking over. It's about building these incredibly powerful tools that can give us, the human managers, detailed analysis and smart recommendations. But the final decision and the ultimate responsibility, that stays in our hands.
So, we're moving from a world where we just use a single AI tool to a world where we're going to be managing entire teams of specialized AIs. And that leaves us with a really fascinating question to think about. As AI gets better and better at building its own teams, what will our role become as the ultimate coordinators of it all?